1962 Pontiac Super Duty 421. In 1962, Pontiac built an engine that blurred the line between a production car and a full-fledged race machine. The Super Duty 421 wasn't just powerful, it was purpose-built to win, and it did so in a way that forced NASCAR to rethink what stock really meant. The foundation of the Super Duty 421 was Pontiac's standard 389 block, enlarged to 421 cubic inches and refined with an engineer's precision. It featured forged steel internals, heavy-duty connecting rods, dual Carter 4-barrel carburetors, and a high-lift camshaft that let it breathe far better than anything else on the track. Officially, Pontiac rated it at 405 horsepower, but everyone in the paddock knew that was fiction. In reality, the best-prepped engines produced closer to 460, sometimes more. What made the Super Duty program truly radical was how far Pontiac went to reduce weight and improve balance. Engineers developed aluminum exhaust manifolds, intake manifolds, and bumpers. They even built ultralight Swiss cheese frames, drilled through with dozens of holes to remove every unnecessary ounce. NASCAR cars of the early 1960s were supposed to be showroom stock, but these were hand-assembled race cars with VIN numbers. The results were immediate. On big ovals like Daytona and Charlotte, the 421 Super Duty Catalinas and Grand Prix models pulled away from the field. Drivers such as Fireball Roberts and Cotton Owens turned the big Pontiacs into dominant forces, routinely finishing multiple laps ahead of the competition. The combination of horsepower and weight reduction made them unbeatable in straight-line speed and endurance. But dominance comes at a price. By early 1963, General Motors' top executives grew uneasy. The corporation had issued a blanket ban on direct factory involvement in racing, fearing antitrust scrutiny and escalating costs. Pontiac's success and the growing publicity around its factory-backed efforts drew unwanted attention. In January 1963, GM ordered Pontiac to withdraw from NASCAR and end all racing activities immediately. It wasn't NASCAR that outlawed the engine. It was Pontiac's own parent company, recognizing that the 421 Super Duty had crossed the line from production car to purpose-built race machine. The decision ended Pontiac's short-lived reign at the top, but left a permanent mark on the sport. The Super Duty 421 became a symbol of an era when engineering creativity ran faster than the rulebook could keep up. It forced NASCAR to begin tightening definitions of stock, equipment, and to monitor how much manufacturers could push under the guise of production models. Within a few years, those lessons would shape how all engines were homologated. The 1962 Pontiac Super Duty 421 didn't just win races. It redefined what a stock car could be, and proved that Detroit's engineers were already thinking more like racers than manufacturers. It was too advanced for its time, and that's exactly why it had to be stopped. 1963 Chevrolet 427 Mystery Motor. In early 1963, Chevrolet arrived at Daytona with something no one had seen before, a 427 cubic inch V8 that didn't appear in any production car and didn't even have an official name. The press called it the Mystery Motor, and it marked a turning point in NASCAR history. The moment the line between factory stock and experimental engineering began to blur. The engine was a prototype for Chevrolet's upcoming Mark IV Big Block. It introduced features that would define Chevrolet performance for decades: canted valves, redesigned cylinder heads with superior airflow, and a stronger block capable of sustaining massive power at high RPM. Officially rated at 430 horsepower, dyno sheets showed it producing anywhere from 500 to 600, staggering numbers for the time. The debut came during speed weeks at Daytona. Junior Johnson and Johnny Rutherford were among the few drivers trusted with cars powered by the new engine. Johnson qualified on the front row for the Daytona 500 and dominated his 100-mile qualifying race, pulling away from the field on the straights with ease. The mystery surrounding the motor only heightened the drama. Competitors and reporters wanted to know what was under the hood, but Chevrolet remained silent. It didn't take long for controversy to follow. Rivals protested, arguing the engine wasn't legal because it had never appeared in a production vehicle. NASCAR's rules required engines to be based on publicly available cars, and the mystery motor clearly wasn't. It was a pure factory racing engine disguised with Chevrolet decals. Behind the scenes, the politics of racing were about to end the experiment. In January 1963, General Motors reissued its corporate ban on all factory racing programs. The move was driven by fear of federal antitrust action and rising costs among GM divisions competing with each other in motorsport. Chevrolet was forced to withdraw its cars and engines from NASCAR immediately, and the mystery motor project was shelved. Only a handful were ever built, but their influence was lasting. The engine's design became the foundation for the Mark IV Big Block introduced in 1965, powering everything from Corvettes to Chevelles to Camaros. Its brief NASCAR appearance showed how quickly manufacturer competition could outpace the rulebook and how easily innovation could collide with regulation. The 427 Mystery Motor's legacy was more philosophical than statistical. It forced NASCAR to confront what stock really meant and to tighten its homologation requirements. From then on, any engine used in competition had to be part of a production car line. Teams could no longer sneak prototypes or engineering exercises into the field under the guise of factory support. For a few days at Daytona, Chevrolet's mystery motor looked like the future. It was lighter, stronger, and faster than anything else on the grid. But it also proved that without clear limits, NASCAR's stock cars could become race cars in everything but name. And that was a future the sport wasn't ready to embrace. 1964 Chrysler 426 Hemi. In 1964, Chrysler unleashed an engine so dominant that NASCAR was forced to rewrite its own rulebook. It was called the 426 Race Hemi, and it changed stock car racing forever. The 426 Hemi debuted at the Daytona 500, with Richard Petty behind the wheel of his blue No. 43 Plymouth Belvedere. The engine was enormous, heavy, and brutally efficient. A 426 cubic inch V8 with hemispherical combustion chambers that allowed air and fuel to flow straight through the cylinder heads instead of around them. The result was unmatched volumetric efficiency. On the dyno, it produced about 550 horsepower at a time, when most competitors were barely clearing 400. When the green flag dropped at Daytona, the difference was obvious. Petty led 184 of 200 laps and won by a full lap. His Plymouth teammates Jimmy Pardue and Paul Goldsmith finished second and third. Chrysler didn't just win, it humiliated the field. Ford and General Motors teams were left with no answer to the Hemi's combination of top-end power and reliability. For NASCAR, it was a warning sign. The engine's hemispherical design wasn't new. Chrysler had used similar architecture in the 1950s, but this race version was built purely to dominate. Its large valves, cross-flow heads, and oversized ports allowed it to breathe better than any stock engine ever had. It was not something you could buy at a dealership, and that was the problem. After the 1964 season, NASCAR President Bill France ruled that the 426 Race Hemi wasn't legal for competition. The reasoning was simple. Chrysler hadn't produced a sufficient number of street-legal cars equipped with it. NASCAR's identity was built on the concept of win on Sunday, sell on Monday, and the Race Hemi failed that test. France insisted that if Chrysler wanted to compete, they'd have to offer a version of the engine to the public. Chrysler executives refused. Instead of detuning their masterpiece, they pulled their teams from NASCAR for the 1965 season in protest. The standoff lasted nearly a year, with Chrysler engineers working behind the scenes to build a homologated version of the engine that could be sold in showrooms. By 1966, they returned with the Street Hemi, a slightly softened version rated at 425 horsepower. It met NASCAR's requirements and quickly restored Chrysler's dominance. But the message had already been delivered. The 1964 Race Hemi had pushed the sport to its breaking point. NASCAR now had to balance competition with accessibility. The Hemi's success forced officials to create stricter homologation standards, ensuring that engines used on the track actually existed in production cars. It was the first time NASCAR explicitly tied technical legality to showroom availability, a principle that shaped the next half-century of stock car racing. The 426 Race Hemi remains one of the most legendary engines ever built. Raw, overpowered, and briefly unstoppable. Its single season of dominance in 1964 didn't just win races. It forced NASCAR to define what a stock car truly was. 1964 Ford 427 SOHC Cammer. In 1964, Ford built an engine so advanced that NASCAR banned it before it ever competed. Known as the 427 SOHC, or simply the Cammer, it was Ford's direct response to Chrysler's Hemi domination. It remains one of the most powerful and controversial engines ever engineered for stock car racing. The Cammer began life as Ford's FE Series 427 block, but from there, engineers reimagined almost everything. They replaced the pushrod valve train with a single overhead camshaft on each cylinder bank. The new heads featured hemispherical combustion chambers and enormous valves that improved airflow dramatically. Power came on fast and kept climbing. The engine could easily rev past 7,000 RPM, producing between 616 and 657 horsepower in race trim. In 1964, nothing else came close. Ford designed it specifically for high-speed ovals like Daytona and Talladega. With its breathing efficiency and ability to sustain power at high RPM, the Cammer promised to bring Ford even with, or perhaps beyond, Chrysler's Hemi teams. NASCAR mechanics called it surgical, and test results suggested it would redefine what a stock car engine could do. But NASCAR President Bill France saw trouble coming. The 427 SOHC never appeared in a production car, which meant it technically violated the sport's stock requirements. It was a pure racing engine, built in Ford's Skunk Works program with no intention of being sold to the public. Its long dual timing chains, unique cylinder heads, and race-only components made it exotic, far removed from anything the average buyer could find at a dealership. France's stance was clear. NASCAR's identity rested on the principle that the cars and their engines had to be rooted in production models. If Ford's overhead cam monster was allowed in, the other manufacturers would follow, and stock racing would turn into a full-blown engineering arms race. Before the 1965 season began, France officially declared the Cammer illegal for NASCAR competition. Ford protested, but the decision stood. The company redirected its efforts to drag racing, where the 427 SOHC quickly became a legend. It dominated NHRA Top Fuel and Funny Car divisions for years, earning a fearsome reputation for durability and sheer speed. The same qualities that made it too advanced for NASCAR made it a perfect fit for the quarter mile. In the end, the 427 SOHC never turned a competitive lap in NASCAR, but its influence was enormous. It forced NASCAR to define its limits, to decide how far manufacturers could push technology under the banner of stock. It also underscored how quickly Detroit's engineering could outpace the rulebook. The Camry stands as one of the greatest what-ifs in racing history. It was an engine built to win at Daytona, capable of rewriting every performance benchmark of its era. Instead, it became a symbol of how innovation in NASCAR would always exist within strict boundaries. Boundaries the Camry itself helped draw. 1966. Chrysler 426 Street Hemi. When Chrysler returned to NASCAR in 1966, it did so with something to prove. 2 years earlier, the 426 race Hemi had obliterated the competition at Daytona, only to be banned the following season for failing to meet NASCAR's production requirements. Chrysler's response was straightforward. If NASCAR wanted a street version, they'd build one and make it just as fearsome. The result was the 426 Street Hemi, a detuned but still ferocious sibling of the race Hemi. To comply with homologation rules, Chrysler built the required 500 streetcars equipped with the engine, offering it in both Dodge and Plymouth models. Officially rated at 425 horsepower, real output was closer to 480. Engineers softened the camshaft profile, swapped the magnesium crossram intake for a cast iron dual-quad setup, and used lower compression to make it marginally more livable for everyday driving. But under the hood, it remained a race engine at heart. Massive ports, hemispherical chambers, and that same distinctive roar. Once NASCAR approved it, the Hemi returned to the track in 1966 with immediate impact. Drivers like Richard Petty, David Pearson, and Buddy Baker brought Chrysler back to the front of the pack. Petty dominated Daytona once again, and by 1967, he was virtually untouchable, winning 27 races in a single season, including 10 in a row, all with the Hemi powering his No. 43 Plymouth. The engine's strength was its combination of reliability and sustained top-end power. On the long superspeedways, nothing could match it. But success came with consequences. NASCAR suddenly found itself presiding over an escalating horsepower war. Manufacturers were pouring resources into increasingly powerful engines, and speeds on tracks like Talladega and Daytona began pushing well beyond what safety infrastructure could handle. Cars were now capable of topping 180 miles per hour, and even the smallest mechanical failure could be catastrophic. To slow things down, NASCAR began tightening engine rules. By the early 1970s, displacement caps reduced engines to 358 cubic inches, effectively ending the big block era that the Hemi had defined. Weight requirements, restrictor plates, and aerodynamics regulations soon followed. The Street Hemi, while still legal for a few years, was no longer competitive under the new constraints. By mid-decade, its run was over. Yet its legacy is impossible to overstate. The 426 Street Hemi redefined the boundary between streetcar and race car. It proved that a manufacturer could build a competitive NASCAR engine, meet homologation rules, and still dominate the sport. Its production run cemented Chrysler's reputation as the builder of America's most fearsome engines, and its mystique continues to this day, both on the track and among collectors. The 1966 Street Hemi wasn't just Chrysler's comeback, it was a turning point for NASCAR itself. It brought speed, spectacle, and engineering brilliance, and forced the sport to ask how much performance was too much for a stock car to handle. 1967 Chevrolet 302 Z28. Between 1967 and 1969, Chevrolet's 302 cubic inch small block became one of the most influential American racing engines ever built. It wasn't created for NASCAR, but its design and success reshaped how the sport thought about displacement, durability, and efficiency, eventually helping inspire NASCAR's 358 cubic inch standard that still exists today. The 302 originated as Chevrolet's answer to the SCCA Trans Am Series 5.0-liter limit. Engineers combined a 4-inch bore from the 327 block with a 3-inch stroke from the 283, producing a high-revving, over-square engine that thrived at RPM levels unheard of for most American V8s of the era. Rated at 290 horsepower for insurance and marketing purposes, race-prepped versions easily exceeded 400 horsepower and could spin beyond 7,000 RPM. The engine powered the Camaro Z28, Chevrolet's track-focused performance model, built to challenge Ford's Mustang in Trans Am. It was light, responsive, and perfectly balanced. An engine designed to live at wide-open throttle. Its solid lifter camshaft, forged rotating assembly, and large port heads made it nearly indestructible under race conditions. Although its intended battleground was road racing, the 302's design philosophy started filtering into NASCAR circles almost immediately. Short-track teams recognized that smaller, freer revving engines could outperform heavier big blocks on tight, high-banked ovals. They weighed less, handled better, and could maintain higher RPM without mechanical failure. By the late 1960s, as NASCAR's superspeedway speed soared and the horsepower war escalated, the 302's engineering lessons began influencing how teams and officials thought about long-term competition. Massive engines like the 426 Hemi and 427 big blocks were fast but costly, and they pushed safety and speed limits to dangerous levels. The industry was realizing that smaller displacement engines could deliver comparable lap times through balance and efficiency rather than brute force. When NASCAR introduced new displacement limits in the early 1970s, gradually phasing out the giant motors in favor of smaller ones, the move reflected what Chevrolet had already proven, that smart engineering could replace raw size. The result was the eventual standardization of the 358 cubic inch limit for the Cup Series, a configuration that still dominates today. The 302 also demonstrated the importance of RPM and breathing efficiency in performance. Its free revving nature and bulletproof reliability became benchmarks for future NASCAR engine development, influencing how teams designed cam profiles, port flow, and valve train geometry. The engine's legacy extended beyond its brief production run. The Z28 name became a performance legend, and the 302 itself became a symbol of balance, the perfect middle ground between street and race, power and control. It showed that displacement alone didn't define dominance, design did. The 1967 Chevrolet 302 Z28 never headlined the Daytona 500, but it changed how NASCAR thought about power. It was proof that smaller could be smarter, and that efficiency, durability, and precision engineering could shape the next generation of stock engines more than cubic inches ever would. 1968 Dodge Charger 500. In 1968, the Dodge Charger 500 became the car that started NASCAR's first aerodynamic revolution. It wasn't built to make headlines in showrooms. It was built to fix airflow, win races, and push the sport into an entirely new era of engineering. The standard 1968 Charger was already a design icon, but on high-speed tracks like Daytona and Talladega, beauty became a liability. The recessed grille and tunneled rear window acted like air traps, creating turbulence that lifted the car's nose and slowed it down on the straights. Ford's sleeker Fairlane and Torino models were faster and more stable, and Dodge's 426 Hemi-powered cars were suddenly struggling to keep up. Chrysler's engineers went back to the wind tunnel. Their solution was the Charger 500, a subtle but significant redesign. They replaced the inset grille with a flush-mounted coronet-style piece, smoothing airflow across the front. At the rear, they ditched the tunneled back glass for a flush fastback window that eliminated the pocket of drag behind the roofline. The changes didn't alter the car's overall look much, but they transformed how it sliced through the air. Under the hood, the Charger 500 carried the same power plants that had made Dodge a threat, the 426 Hemi and the 440 Magnum. On paper, those engines already had the muscle. Now they finally had the aerodynamics to match. In testing, the car picked up as much as 10 miles per hour of top-end speed, a massive improvement for NASCAR's long superspeedways. The results came quickly. In 1969, the Charger 500 helped Dodge return to the front, with drivers like Charlie Glotzbach and Bobby Isaac taking wins and poles. But it wasn't the end of development. It was the beginning of escalation. Ford fired back with the Torino Talladega, a purpose-built aerodynamic special that pushed even further into wind tunnel refinement. Chrysler responded again with the Charger Daytona, which added a 23-inch nose cone and a towering rear wing. The Charger 500 had unknowingly sparked the first aero war in NASCAR history. That arms race forced NASCAR to act. By 1971, speeds had surpassed 200 miles per hour, far beyond what tracks and safety equipment were designed to handle. The sanctioning body stepped in with new rules, limiting aerodynamic aids and restricting engine displacement. The Charger 500 itself was never banned, but its existence had pushed the sport toward regulation. The car's legacy is in its influence. It proved that horsepower alone wasn't enough to win. Aerodynamics mattered just as much. It was the first NASCAR car designed using airflow science rather than styling trends, and it set the blueprint for everything that came after, from the Daytona to the modern wind tunnel machines of today. The 1968 Dodge Charger 500 didn't just fix a drag problem. It changed how stock cars were built. It was the first step in NASCAR's transformation from brute power to aerodynamic precision, and the moment racing engineers began learning to shape the air itself. 1969 Ford Boss 429. In 1969, Ford built the Boss 429 for one purpose: to win in NASCAR. It was not a marketing exercise or a design statement. It was a weapon built in response to Chrysler's 426 Hemi, and it remains one of the most over-engineered engines ever approved for competition. At the heart of the project was Ford's desire to dominate NASCAR's superspeedways, where horsepower and durability mattered more than anything else. The 429 cubic inch V8 that came out of Dearborn was radically different from Ford's existing big blocks. It used a semi-hemispherical combustion chamber design with canted valves and huge ports that allowed incredible airflow at high RPM. The block was forged and reinforced to handle the stress of sustained wide-open throttle at over 7,000 RPM, something few engines of the time could survive. To meet NASCAR's homologation rule, Ford had to build at least 500 street cars using the engine. The standard Mustang wasn't designed to fit such a massive power plant, so the company contracted Carcraft in Brighton, Michigan, to hand-modify each chassis. They widened the engine bay, moved shock towers, and reworked front suspension geometry just to make it fit. The resulting Mustang Boss 429 was one of the most aggressive street cars Ford had ever built, officially rated at 375 horsepower, though race versions comfortably exceeded 600. On the track, the Boss 429 proved its worth. Paired with the aerodynamic Torino Talladega, it propelled Ford and Mercury teams to dominance in 1969. Drivers like David Pearson, Cale Yarborough, and Leroy Yarborough scored key victories, helping Ford secure 26 wins that season and a manufacturer's championship. The combination of Ford's wind tunnel bodywork and the Boss 429's power made them nearly unbeatable on high-speed ovals. However, the Boss 429 also signaled the point where technology and regulation began colliding. The engine was expensive to produce, difficult to service, and far beyond what could reasonably be considered stock. As speeds climbed and the aerodynamic arms race intensified, NASCAR grew concerned about safety and accessibility. By 1971, the sanctioning body introduced new rules, limiting engine displacement and restricting aerodynamic body shapes, effectively phasing out the ultra-specialized big blocks, like the Boss 429 and Chrysler Hemi. Despite its short run, the Boss 429 left a lasting legacy. It represented the peak of Detroit's late 1960s engineering freedom, when manufacturers treated NASCAR as a laboratory and race teams were extensions of corporate research. The lessons learned from the Boss 429's valve train, cooling, and high RPM endurance influenced Ford's performance engines for decades to come. Today, the Boss 429 is remembered as both a racing legend and a collector's dream. It was the moment Ford built a streetcar solely to satisfy NASCAR's rulebook, and in doing so, they created one of the greatest engines in American history. The Boss 429 wasn't built to last forever. It was built to win, and for one brief window, it did exactly that. 1969, Chevrolet ZL1 Aluminum 427. In 1969, Chevrolet built an engine that pushed NASCAR's definition of stock to its limit. The ZL1 427 was the most advanced big block of its time, a lightweight aluminum masterpiece that combined brute force with aerospace-level materials science. It was powerful, exotic, and so far ahead of the curve that NASCAR quickly moved to close the door behind it. The ZL1 started as an evolution of Chevrolet's L88 program, which had already made the 427 cubic inch Corvette a legend. But this version went further. Every major component, block, heads, and intake, was cast in aluminum. It used open-chamber cylinder heads with massive valves and an 850 CFM Holley carburetor that allowed the engine to breathe freely at high RPM. It came from the factory with a forged steel crankshaft, heavy-duty rods, and 12.5-to-1 compression pistons. Chevrolet conservatively rated the ZL1 at 430 horsepower, but in race trim, it easily made more than 550. Even more impressive was the weight. The aluminum block cut nearly 100 pounds compared to a standard iron 427, giving cars better balance and acceleration. It was an engineering experiment, born from Chevrolet's Central Office Production Order (COPO) program, designed to test the limits of what could be sold and raced as a production car. Only a handful of street cars ever carried the engine, 69 Camaros and a few Corvettes. But the ZL1's true purpose was competition. Chevrolet engineers and race teams saw it as the next step in bridging drag racing and NASCAR, a platform that could be tuned for lightweight endurance while delivering massive output. The combination of high strength, low weight, and durability made it a potential game-changer. That potential also made it a problem. By the time the ZL1 began showing up in testing and smaller events, NASCAR officials were already wary of the direction factory engineering was heading. The ZL1 wasn't just fast, it was expensive and used materials that other manufacturers couldn't easily match. If left unchecked, it risked turning NASCAR into a contest of corporate budgets, instead of driver skill and mechanical ingenuity. The sport's stock car identity was at stake. NASCAR quickly moved to restrict the use of aluminum engine blocks, mandating cast iron construction for all eligible power plants. The decision effectively sidelined the ZL1 from top-tier competition before it ever had a chance to dominate. Teams could still use its technology in other forms of racing, but its pure aluminum block was off-limits for NASCAR. Even with its limited run, the ZL1 left a massive legacy. It proved that weight reduction could be just as valuable as raw horsepower, and showed how far manufacturers were willing to push engineering within the rulebook. It influenced decades of engine design, from NASCAR's eventual emphasis on parity and material control to Chevrolet's later generations of lightweight racing engines. The 1969 Chevrolet ZL1 427 was too advanced for its era. It blurred the line between production car and prototype, forcing NASCAR to confront the future of racing technology. It was the engine that taught the sport a new lesson. Sometimes, innovation has to be slowed down to keep competition alive. 2007 Toyota TRD NASCAR engine. When Toyota entered NASCAR's Premier Series in 2007, it brought with it an engine that forced the sport to modernize. The Toyota Racing Development, TRD, V8, wasn't a reworked old block or a holdover from decades of production car heritage. It was a clean-sheet racing engine designed specifically for NASCAR's 358 cubic inch rule. That alone made it controversial and revolutionary. At its core, the TRD NASCAR engine followed the same basic architecture as its competitors: 90-degree V8, 2 valves per cylinder, push rods, and a single 4-barrel carburetor. But what set it apart was how meticulously it was designed and built. Instead of evolving a street-based platform, Toyota used modern computational modeling, CNC machining, and precision casting to create an engine engineered from the ground up for balance, airflow, and reliability. The block and heads were compact and symmetrical, improving airflow and making the engine easier to service and tune. The valve train geometry was optimized to reduce friction and allow higher RPM without the durability issues that plagued older designs. TRD's engineers also perfected the oiling system and cooling passages to deliver consistent performance across 500 miles of racing at full throttle. Everything about it screamed precision and uniformity, qualities rarely associated with stock engines. When Toyota's Cup program debuted with teams like Michael Waltrip Racing and Red Bull Racing, the carmaker faced intense scrutiny. Traditionalists accused Toyota of exploiting loopholes by introducing an engine that, while legal, represented a level of design sophistication the American manufacturers hadn't matched. Rivals claimed it wasn't in the spirit of NASCAR's production-based philosophy. NASCAR officials launched several technical reviews to ensure the TRD motor conformed to the sport's strict dimensional and materials rules. It did, but the controversy changed NASCAR's approach to how new engines were approved. Officials began tightening the specifications for bore spacing, deck height, port shape, and combustion chamber design, limiting how much new manufacturers could innovate within the existing template. Parity became the guiding principle, ensuring that competition wouldn't be decided by corporate engineering budgets. Despite the pushback, Toyota's investment paid off. By 2008, the TRD engine had matured into one of the most reliable and powerful in the field. Kyle Busch, Denny Hamlin, and Tony Stewart soon turned Toyota into a consistent winner. The engine's efficiency and longevity set a new standard for quality control across the grid. Over time, NASCAR incorporated many of the lessons the TRD engine brought, standardizing inspection processes, adopting more consistent technical templates, and modernizing the approval system for new engine parts. Toyota's presence accelerated the sport's transition from factory-style tuning to professionalized engine development. The 2007 TRD NASCAR V8 didn't break the rules, it forced NASCAR to evolve them. It represented the next stage of the sport's engineering evolution, where data, precision, and manufacturing discipline became as important as horsepower. For Toyota, it was a statement. They could play by NASCAR's rules and still change the game entirely.